first video of the playlist. In this video, I want to tell you about CUDA C. Prerequisites. Before starting the series, you should have the knowledge of C or C++, memory allocations, pointers. For the beginners level, you do not need to understand the architecture of the GPU you're gonna use, but it would be beneficial if you have little understanding of GPU. You don't need to have any graphics experience or graphics programming. You don't need to have any parallel programming experience. Okay, let's start. So, first of all, you need to know about CUDA. CUDA stands for Compute Unified Device Architecture. It is a platform which was developed by NVIDIA. It is the architecture of the device performing the unified computations. This could be considered as a computing engine using which you can execute your computational code on GPU instead of CPU. Now, the second term is GPGPU. Many of you would be familiar with this term. GPGPU stands for General Purpose Computing on Graphics Processing Units. Today, GPUs are not only used for graphics processing, not for only enhancing your gaming experience. These are also used for executing the computational code of the program. Many programming languages have the extension for CUDA like C, C++, Fortran, Python, etc. A CPU contains some cores which have more power, whereas GPU have many cores but with less power. Okay. Let me show you on my system. Okay, I'm using i5 5200U CPU. It has 2 cores and 4 logical processors, each with 2.20 gigahertz. Now, let me show you CUDA. CUDA control panel, NVIDIA control panel. NVIDIA control panel, the information about system. You can see it has 384 CUDA cores. 384 CUDA cores. Okay. CPU have clock speed in gigahertz. GPUs have clock speeds in megahertz. Okay. So what is CUDA C? It is C-like programming language to execute the program on GPU using CUDA tools. CUDA C provides heterogeneous computing. Heterogeneous computing. Now let's talk about what is heterogeneous computing. In heterogeneous computing system, different types of cores and processors are being used, like CPU and GPU. In heterogeneous computing, core processors like GPU in case of CPU enhance power of the system. Heterogeneous system with respect to CUDA C. CPU is called as host and its memory is called as host memory. As GPU is called as device and its memory is called as device memory. Okay, so let's see how this model works. What is the concept behind this model? Okay. When user gives the code to CPU for execution, input data is being copied to the device memory. Then the computational code is divided into many threads and executed on GPU cores parallelly, and the result is being copied to the host memory. So why we use heterogeneous computing? Why? Why heterogeneous computing? GPU processing, apart from its well-known 3D graphics rendering capabilities, can also perform mathematically intensive computations on very large data sets, while CPUs can run the operating system and perform traditional series tasks. This model is used for some specific tasks, as when you have to find factorial of a large integer like 500, then you can run the computational part on the GPU. As I told you, GPUs have many cores which can provide massive parallel computing. Massive parallel computing is a type of computing in which threads are being executed simultaneously. Heterogeneous computing boosts the performance and accelerate the computation by performing parallel computation. What you need to start the programming with CUDA C, so Visual Studio and CUDA Toolkit. That's it. One question for you. Okay, one question for you. If GPUs are so strong in computing, they have many cores, can perform parallel computations. They can perform parallel computational tasks and accelerate the efficiency of the program. So why we don't replace the CPUs with GPUs? Okay, that's it for now. Every week I'm gonna add a new video in the playlist. So interested persons, please subscribe. This knowledge is free for everyone. So please share this. Yes, please comment your answers. Thank you.